Today I will be controlling some high voltage devices using a relay, which is like an electromechanical switch. So it uses an electromagnet to mechanically move contacts that open or close a circuit. So with a low power signal, I can control a high power circuit. And basically the way how it works is that when the coil of the relay is connected to a supply voltage, it gets energized. So the common contact, which is a moving contact, gets connected to the normally open contact. And when the coil is de-energized, it switches back and the common contact is now connected to the normally closed contact. So in this schematic, the relay is powered through a NPN transistor, which acts as a switch that is controlled by the signal from the in pin. So the in pin sends a low current signal to the base of the transistor, which allows current to flow from the collector to the emitter. Then this current energizes the relay coil, causing it to switch. And when the current stops, it switches back. But there is a twist. When the current flows through the coil, it stores an electrical energy in form of a magnetic field. So when the coil is de-energized, this magnetic field collapses and the coil tries to release this energy. So its voltage rises and the polarity across it flips and tries to keep the current through, and as there is no low resistance path for the current to flow, this high voltage spike will try to find a path to discharge, and it will attempt to discharge through the transistor, which can potentially kill it. So this is why a flyback diode is placed across the relay coil, and this diode is placed in reverse bias relative to the normal operating current, which means that when the voltage spike occurs, this diode provides a path for the induced current to circulate through the coil back to the diode, safely dissipating the energy without letting it affect the rest of the circuit. So now to control the relay using an Arduino microcontroller, we connect the VCC pin to 5V pin on the Arduino, GND to GND, and the in or signal pin to a digital pin on the Arduino. Let's say I want to control a lamp powered from an AC source to a relay. So I will connect the neutral wire directly from my power source to one end of the lamp and the hot wire to the common terminal of the relay, and the other end of the lamp to the normally open contact. When the relay is activated, the normally open contact will close, completing the circuit and allowing current to flow to the lamp. And I have added a push button on the breadboard so that every time I press the push button, the relay switches and the lamp will toggle between turning on and off.